All right, in this video, we're going to pick up where we left off last time with 4.2. Last time we talked about summation notation and finding approximations of area under a curve using lower sums and upper sums. And we talked about our summation formulas that we're going to be using when we have n rectangles where n is not defined. And we're going to be using those again, but we're going to be using the limit process, and the limit process is going to help us squeeze out all of the air. So the idea here, see if I can draw a picture, is if I have, say, this type of a curve, and instead of maybe making 6 rectangles and then making 10 rectangles and then making 20 rectangles and trying to squeeze out the air by making more and more rectangles, if I could make infinitely many rectangles that are infinitesimally small in width and stack them next to each other, I'm essentially, and the rectangles are going to go up and touch the top of the function, so that the functions is the height of the rectangle here, that this is y equals 0, this is y equals f of x. The f of x will be my height of my rectangle, delta x will be my width, and I'm going to let delta x go to 0 because the formula for delta x is b minus a over n, and really I'm going to let n go to infinity, and that's going to force this delta x to go towards 0 because any constant over infinity is going to approach 0. So I essentially am just going to get shading under the curve like this, where it just colors in everything with all of those infinite rectangles like that I'm going to have, and it's going to give me the exact area when I can do this. I made a shape that was too big that I have to do too much coloring, but I think you understand what I'm saying, that I wouldn't have any white space if I could color this in, shade it exactly right. So just this rectangle, that rectangle, that rectangle, all stacked next to each other, infinitely many here, are going to color in the exact area of this shape. All right, I'm going to clear that, but that's the idea of what we're doing in this video, is to squeeze out all the air with this limit process. So 49 tells us that y is equal to x squared plus 2, 0 to 1, and I use the limit process to find the area of the region bounded by the graph, sketch the region. So we're going to do a little bit of drawing. So I'll let my calculator do the drawing for me. Don't worry about the function on the calculator that I'm showing you, but I'm going to stick in here x squared plus 2, second calc, and I'm going to use number 7 down here. And I'm going to go from 0 to 1. I'm going to let it shade that blue area in right there. It's telling me that the answer is 2.3, or 2 1/3, so this should be 7/3. Calculator is doing that for me. Let's see if I get this answer with the limit process here. So delta x is b minus a over n is 1 over n. I'm going to define ci as a plus I delta x, where this is A, this is B, C is going to be something that's in between A and B. So this is really my right endpoint, is what I've defined C as. 0 plus I times 1 over n is I over n in this case. So my f of, let's call this f of x, my f of ci will be my height here. At ci is going to be I over n squared plus 2 is I squared over n squared plus 2. And I need f of ci times delta x because I need my height times my width to get my little areas here of my rectangles. So this is I squared over n squared plus 2 times I over n, no, times 1 over n. Delta x is 1 over n. So this is I squared over n cubed plus 2 over n. So this is the inside of my summation here. My formula is going to say A is equal to the limit as n goes to infinity of I equals 1 to n of f of ci delta x. I found the f of ci delta x. I just need to stick it into this formula. A is equal to limit as n goes to infinity, summation I equals 1 to n of all this that I just found, I squared over n cubed plus 2 over n. And now I'm going to use my summation formulas that we talked about last time. Limit as n goes to infinity of summation I squared, going to pull this out, plus 2 over n summation I equals 1 to n of 1. That is A is limit n goes to infinity of 1 over n cubed. And then I squared is n times n plus 1 times 2n plus 1 over 6 plus 2 over n times n. That goes away. This is an n squared. Area equals limit as n goes to infinity of 6n squared. This is 2n squared plus 3n plus 1 plus 2. So this is area is equal to limit n goes to infinity of, that's just going to be a plus 2 out there. This is divide everything by n squared. This is 2 plus 3 over n plus 1 over n squared over 6. And as we go to infinity, anything with an n in the denominator goes to 0. 2 plus 0 plus 0 over 6 plus 2 is 2 over 6 plus 2 is 2 1/3 is 7/3, just like we said the answer was going to be. Look now at number 51. 51 says y equals 25 minus x squared on the interval of 1 to 4. So y equals 25 minus x squared, and graph that. And we're going to go second calc 7 from 1 to 4. And says that A is going to be 54. Let's go ahead and let's check that. Delta x is 4 minus 1 over n, or 3 over n. This is f of x. Ci is a plus I delta x. 1 plus 3i over n. F of ci is 25 minus 1 plus 3i over n quantity squared is 25 minus 1 plus 6i over n plus 9i squared over n squared. F of ci is 24 minus 6i over n minus 9i squared over n squared. F of ci times delta x is 24 minus 6i over n minus 9i squared over n squared times 3 over n is 72 over n minus 18i over n squared minus 27i squared over n cubed. So A equals limit as n goes to infinity of the summation I equals 1 to n of 72 over n minus 18i over n squared minus 27i squared over n cubed will be limit n goes to infinity of 72 over n summation I equals 1 to n of 1 minus 18 over n squared summation I equals 1 to n of I minus 27 over n cubed summation I equals 1 to n of I squared is limit as n goes to infinity of 72 over n times n minus 18 over n squared times n plus 1 over 2 minus 27 over n cubed times n times n plus 1 times 2n plus 1 over 6. So this is limit n goes to infinity of 72. This is 9. This is n minus 1 plus 1 over n. This is 9. This is 2. This is n squared. This is minus 9 over 2n squared. 2 times, let's put the n squared down here, 2n squared plus 3n plus 1 is limit n goes to infinity of 72 minus 1 is 71 minus 1 over n, and then this is minus 9 halves times 2 plus 3 over n plus 1 over n squared, and take the limit of all these things with n's in the denominator. So this is limit as n goes to infinity of, let's see, (72) minus, this is 9, is 63 minus 9 over n. Let's see, and then so we'll have 63 minus another 9 is 54. And there's our 54. That was our answer right there with our limit process. Let's look at number 53. F of x is equal to y is equal to 27 minus x cubed from 1 to 3. You may be thinking, based off of what I've been doing with my calculator, why would anybody do this by hand if we can just do it with a calculator? Well, we didn't always have the calculator for one thing. You're not always going to have a calculator with you, and it is possible to do this by hand with a basic calculator. Without a graphing calculator, if all you have is a 4-function calculator or even a scientific calculator, you can do this. And I think I already mentioned this before, that we're going to run into some functions where we are not going to be able to do this with any other process other than by hand. The calculator is really doing the by hand way behind the scenes. Here, when we graph, we're going to go from 1 to 3. Tells us that our area here is going to be 34. Let's go ahead and find our delta x. 3 minus 1 over n is 2 over n. Ci is 1 plus I delta x, 1 plus 2i over n. F of Ci is equal to 27 minus 1 plus 2i over n to the third. Okay, we haven't done a lot of stuff with third powers, so remember that I'll just write this kind of down here, that a plus b to the third is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So this is f of Ci is 27 minus, so 1 cubed is 1, plus 3 times 1 squared is 1, times 2i over n, plus 3 times 1 times 2i over n squared, plus 1 times 2i over n cubed. F of Ci is 27 minus 1 plus 6i over n, plus 4 times 3 is 12i squared over n squared, plus 8i cubed over n cubed, is f of Ci is 26 minus 6i over n minus 12i squared over n squared, minus 8i cubed over n cubed. F of Ci times delta x is 26 minus 6i over n minus 12i squared over n squared minus 8i cubed over n cubed times 2 over n. It's going to be 52 over n minus 12i over n squared minus 24i squared over n cubed minus 16i cubed over n to the fourth. So exact area is limit as n goes to infinity, summation I equals 1 to n of 52 over n minus 12i over n squared minus 24i squared over n cubed minus 16i cubed over n to the fourth. So a is equal to limit n goes to infinity of 52 over n, summation I equals 1 to n of 1 minus 12 over n squared, summation I equals 1 to n of I minus 24 over n cubed, summation I equals 1 to n of I squared, minus 16 over n to the fourth, summation I equals 1 to n of I cubed. A equals the limit as n goes to infinity of 52 over n times n minus 12 over n squared times n plus 1 over 2. Minus 24 over n cubed times n plus 1 times 2n plus 1 over 6. And minus 16 over n to the fourth times n squared times n plus 1 squared over 4 minus 4 or n squared plus 2n plus 1. Limit n goes to infinity. A equals limit as n goes to infinity of 52 minus 6 times 1 plus 1 over n minus 4 times 2 plus 3 over n plus 1 over n squared minus 4 times 1 plus 2 over n plus 1 over n squared is 52 minus 6 minus 8 minus 4. 52 minus 18 is 34, and that is my exact answer for my area. Let's look at number 55 now. F of x is equal to y is x squared minus x cubed on the interval from -1 to 1. My exact area is going to be x squared minus x squared minus x to the third. Graph that, and then calc 7, -1 to 1, and my answer is 2/3. So delta x is b minus a over n. Ci is a plus I delta x is -1 plus I times 2 over n. Ci is -1 plus 2I over n. F of Ci is I'm going to rewrite f of x as x squared times 1 minus x. Then f of ci is -1 plus 2i over n squared, 1 minus -1 plus 2i over n. So f of ci is -1 squared is 1, minus 2 is minus 4i over n, plus 4i squared over n squared. 1 plus 1 is 2, minus 2i over n. I see a common factor of 2 that I'm going to pull out here. Minus I over n times 1 minus 4i over n plus 4i squared over n squared. The f of ci is 2 times 1 minus 4i over n plus 4i squared over n squared, minus I over n plus 4i squared over n squared, minus 4i cubed over n cubed. Let's simplify. F of ci is 2 times 1 minus 5i over n plus 8i squared over n squared minus 4i cubed over n cubed. -5, +8, -4. So f of ci delta x is 2 times 1 minus 5i over n plus 8i squared over n squared minus 4i cubed over n cubed times 2 over n. So this is f of ci delta x is equal to 4 over n times 1 minus 5i over n plus 8i squared over n squared minus 4i cubed over n cubed is f of ci delta x is 4 over n minus 20i over n squared plus 32i squared over n cubed minus 16i cubed over n to the fourth. So exact area is going to be limit as n goes to infinity, summation I equals 1 to n, 4 over n minus 20i over n squared plus 32i squared over n cubed minus 16i cubed over n to the fourth. This is a is limit as n goes to infinity of 4 over n summation I equals 1 to n of 1 minus 20 over n squared summation I equals 1 to n of I plus 32 over n cubed summation I equals 1 to n of I squared minus 16 over n to the fourth summation I equals 1 to n of I cubed. A equals limit as n goes to infinity of 4 over n times n minus 20 over n squared times n plus 1 over 2 plus 32 over n cubed times n plus 1 times 2 n plus 1 over 6 minus 16 over n to the fourth times n squared times n plus 1 squared over 4. N's cancel. And as n goes to infinity of 4, 2's cancel, n's cancel, minus 10, n plus 1 over n, 3, 16, 16 thirds, 2n squared plus 3n plus 1 minus 4 n squared plus 2n plus 1. So this is a is limit as n goes to infinity of 4 minus 10 times 1 plus 1 over n plus 16 thirds times 2 plus 3 over n plus 1 over n squared minus 4 times 1 plus 2 over n plus 1 over n squared, and everything with an n in it is going to, and the denominator is going to 0 as n goes to infinity. So this is 4 minus 10 plus 32 over 3 minus 4 is A is 4 minus 4 is 0. 32 over 3 minus 10 is 30 over 3 is 2 over 3, which is my exact answer for what my area is. Let's look now at 57. Now these just change the variables to y, but it doesn't change anything. I'll still graph them in terms of x in my calculator. F of y is equal to 4y on the interval 0 is less than or equal to y is less than or equal to 2. And sketch the graph of the region. Well, okay, so I'm going to have to kind of sketch the graph of the region by hand because we have x equals 4y. That's the same thing as y equals 1/4 x. Let's see here. Y equals x over 4 so that I can get the picture right. And if x is going from 0 to 8, when I stick in these limits here, so second calc 7, 0 to 8, and my answer should be 8 for my area, and this should be from 0 to 8. This is 0 to, this is 8, 2. This is y is 2. My rectangle should be going horizontally this time. That's what's going on. I'm coloring in everything instead of rectangles going vertically. I should have actually this side here from here to there. which because of the symmetry, it's the same thing. With the area is what I just found over on the other side. But I should be touching this x equals 0 to x equals 4y, going from y equals 0 to y equals 2. Okay, so let's go ahead and let's figure this out now that delta y is 2 minus 0 over n is 2 over n, and that ci is a plus I delta x, ci is 2I over n, and that f of ci is 4 times 2I over n is 8I over n, and we have f of ci delta y is 8I over n times 2 over n is 16I over n squared. So area is equal to limit as n goes to infinity, summation I equals 1 to n of 16I over n squared. Limit as n goes to infinity of 16 over n squared, summation I equals 1 to n of I is 16 squared. So limit as n goes to infinity, 16 over n squared, n times n plus 1 over 2 is limit as n goes to infinity of 8 times 1 plus 1 over n is 8 times 1 is 8. Look now at number 59. Sketch this. Have y squared. Y goes from 0 to 5. So y is 5. This is 25, 5 out here. 0, 0. I should be going this way here, coloring in all that from x equals 0 to my function. Let's figure out what that is here. This is f of y is y squared, 0, 5. Delta y is 5 minus 0 over n is 5 over n. Ci is 0 plus I times 5 over n is 5I over n. And f of ci is 5I over n squared is 25I squared over n squared. And then f of ci times delta y is 25I squared over n squared times 5 over n. F of ci delta y is 125I squared over n cubed. Area is the limit as n goes to infinity of summation I equals 1 to n of 125i squared over n cubed is equal to the limit as n goes to infinity of 125 over n cubed, summation I equals 1 to n of I squared. A is limit n goes to infinity 125 over n cubed times n plus 1 times 2n plus 1 over 6. And this is n goes to infinity of 125 over 6 times, this is n squared, 2n squared plus 3n plus 1 is limit n goes to infinity of 125 over 6 times 2 plus 3 over 3 over n plus 1 over n squared is A is 125 over 3. That's my correct answer. If I wanted to find that with the calculator, I'd have to do a little bit of work here to say what is this entire area from, see, it's 5 high and 25 wide. That's 5 times 25 minus, and then let's get this formula here of y equals the square root of x. And we want to get second calc 7 from 0 to 25. I need to make my window bigger. Window needs to go from 0 to 25, and from 0 to 10 is fine. Second calc 7, 0 to second calc 7, 0 to 25 is 83 and a third. So 125 is let's see, 83 and a third. 83 times 3 plus 1 is 250. And then 375 over 3 minus 250 over 3 is 125 over 3, which is what my exact answer is. So I can verify that with my calculator a little bit. I still have to do some work to change it into a function of x, and then it's actually going to be doing vertical rectangles here from x equals 0 up to the function. So I have to get the whole box and then subtract off the part that I don't want to get the part that's shaded between the y-axis and the function as a function of y. Otherwise, I could just switch the variables around and get the answer, and it would work. So if I just said f of x is equal to x squared, and I wanted to integrate this, not integrate, but find the area under the curve from 0 to 5. Then I'll get 41 2/3, which is 41 times 3 plus 2 is 125/3, which is my exact answer. So I can do a change of variable as well and get the answer. I just won't get the correct graph here if I'm supposed to sketch the curve. Okay, that's it for this video. And we'll come back next time and we will talk about 4.3. See you for the next video.